Hi, in this video I will now show you a quick overview of the Model Gateway software. Model Gateway was built to automate modeling in online analyzers. It is done by AI algorithms that build chemometric models automatically with no manual operations required by the user. It's a software product with a small footprint that can connect to any analyzer, NIR, Raman, NMR, or any analyzer that requires chemometrics, and it takes care of the modeling, the prediction, and DCS communication. So the software has three interfaces. The first is the analyzer interface. This interface is used for automatically collecting every new spectrum that is being acquired by the analyzer. The spectrum is being loaded and saved into the Model Gateway local database. The second interface goes to the lab data, where lab data can be loaded either manually or automatically over the network from a LIMS software into the Model Gateway database. Once spectra and lab data were loaded into the database, the Model Gateway builds the model for every property, and the models are being saved for further usage. The next spectrum that will be acquired from the analyzer will be predicted using the current model, and the prediction will be sent to the DCS over Modbus or OPC. The Model Gateway software, it's a software-only solution. It can be installed on any Windows machine with a small footprint. It supports any analyzer. It generates models automatically. It's an infrastructure solution, so it takes care of modeling, prediction, and communication. It includes advanced signal processing, graphic tools for model evaluation, and data comparison with lab. It does a validation automatically based on lab data feedback, and it can predict an unlimited number of properties. So that's what the application looks like. The main screen displays a table of all the monitored property, a line for each one. Each property has a unique name, the source probe the spectrum was acquired from, the current model name, and the last prediction value, M distance, and timestamp. Click on each line to see the time chart of this selected property. Select multiple lines for a comparison chart that displays all of them on the same time chart. Comparing to lab data is done by right-click every property and select Compare to Lab Data, where you can see in red line, you can see the prediction graph, and the green dots are the lab data points. Right after installation, the software will ask for configuration of three types of data. The first is the analyzer. We can select one of all the supported analyzers, and each one has a unique set of configuration parameters. The second one will be the DCS connectivity. It can be either OPC or Modbus, client or slave. Again, each one has its own set of configuration parameters. Modbus can be defined either Ethernet or serial. And the last thing we need to configure is the analysis definition, which means which properties are going to be analyzed. That's actually the same grid table as we see on the main screen. That's where it's being defined. So each one has a name, a probe, the source probe it came from. Dynamic model will tell the software to run automatic modeling. And then based on the DCS connectivity, the DCS interface fields will be defined here. Process script we'll discuss later on, and that's it. So saving the data, and we have a new property saved into the database. There it shows up here. No predictions yet. Just here waiting for the next acquisition from probe 3. So after we configure the system, I will now show you how to look and handle the data that was loaded. So the first type of data is the spectra. Spectra can be loaded either manually or automatically into the database. We can see the spectra from the spectra viewer. It shows all the properties and the probe data was acquired from. Clicking on each time point will show it's the spectrum that was acquired at this point in time, and multiple selection will show comparison of all those spectra points. In this case, we can see that there is a bias generated by the analyzer. This bias can be fixed. It is done by writing a script, and we'll go deeper into script editing in a separate video. For now, we'll just select one of those scripts that will fix all those bias issues. And this is the spectra that was loaded into the database. The second type of data is the lab data. So we can click lab value. This table of lab data can be loaded into the system either manually, just copy and paste from Excel, or automatically from a LIMS extension that comes with the model gateway. In this case, the user uses the LIMS software to load data on a central location, and the data propagates to all the analyzers. LIMS will be explained in a separate video. Okay, so now that lab data and spectra were loaded into the database, the next step is to run the modeling. So modeling is as simple as selecting the properties we wish to remodel. Right click on them and select the rebuild model. Now the modeling process will start running in the background. We can see the percentage of the progress, and when we reach 100%, the new models are ready, stored in the local database, and will be used on the next acquired spectrum. We will. It can take a few minutes to a few hours, so we will skip to the end of it. Okay, so the modeling process is complete. We can see that the name of the new model contains the current timestamp. The new model did not override the previous one. Both of them still exist, but the new one is now being used for predicting new acquired spectra. The reason both of them are still saved on the system is that we can always roll back to every previous model that was used in the past, unless we decide to delete all of them and just keep the latest one, which is a configuration option. So the model were automatically put into process. Some users may say that this is something they want to control, and there is the option to control it. It is called, we call it the pending model. And the way it is being managed is this checkbox that says that a new model requires user approval. If we had this option checked, and it will be better explained in a separate video, we run in semi-automatic mode, which means that every new model created will be put in pending mode until the user specifically approves the new model and puts this model into process. In case we want to see how the modeling progress is running, we can use a visual tool called the Model Builder. In this tool, we select the property we want to remodel. We can select the pre-processing script out of the list. The default will be the one that is being used by default for this property. We can limit the max number of factors. We can define the convergence criterion for the algorithm. It can be standard error of prediction, R squared, or M distance. We can define the testing set method, and then we just click the run button. As we see, the standard error of prediction shown, it shows 0.245 now with 7 factors, dropped now to 211, and this number will keep on dropping as the algorithm is moving forward and finding better training sets for modeling. And as you can see, the correlation points between the lab data and the predicted data are getting tighter to the central line as the algorithm progresses. We can see the progress bar. If we wait a few more minutes, this number will reach 100%, and we will see the final model. At every point, we can pause or stop the modeling progress. So in this case, we will just stop it, and in the current model that we have that produced a standard error of prediction of 0.15 with 7 factors, we can just click this button to put this model into process. Once we do it, it will replace the current model that we have for this property. Okay, so the new model was put into process. So this is a graphic tool that provides a similar view to manual modeling tool, except for the fact that it is done automatically. A model analysis tool is available for a deeper view of every model for every property, and it shows the number of coefficients and how many training set points were selected, number of factors, bias, R squared, standard error of prediction, and it can show for every point spectra. It can be either processed or unprocessed, and this tool provides a deep view into the generated model. So to summarize, Model Gateway is a very simple tool to use. There are no special skills required to manage the modeling. It can respond very fast to changes in the analyzer or sample or the environment. Changes can be handled in a matter of hours, unlike days or weeks when doing manual model calibration. There is no need to compromise on the number of properties. In fact, we have systems running over 100 components. You can imagine what it means to maintain over 100 models when things are changing. It's an infrastructure solution. It takes care of the modeling, the prediction, communication, and reporting. And as a software product, Model Gateway can be installed in evaluation mode with full functionality, unlimited number of properties, until reaching the desired results and fully integration with the DCS before making a decision. That's it. Feel free to contact us if you have any questions or you want to see a live demo of the system.